articles. He got several awards like Best Poster Award at National and International Conference, and she is also life membership of IDA and Sunnet. Now, with this word, I welcome Dr. Sonam for her lecture. Over to you, Sonam.
Thank you very much, Dr. Anuradha ma'am. First of all, I would like to thank to the organizing committee, NEDCL and SGIDT Patna for giving me an opportunity to deliver a lecture or talk on the current development in dairy science and technology field. So first of all, good afternoon to one and all participants. This is Sonam Kumari, Assistant Professor in Department of Dairy Technology, Sanjay Gandhi Institute of Dairy Technology, Patna, under Bihar Animal Sciences University, Patna. So my topic is oleogels, application in dairy and food industry. So why I choose oleogels? Because this is a very heated topic currently in the dairy field on global level. So I will explain why there is need of concept to bringing up oleogel in the dairy and food industry. What are the methodology to prepare the oleogels? What are the mechanism to behind the preparation of oleogelation? And why is the opportunity or application in dairy and food? Related to this studies, I will also discuss the case studies which is happened in a few years ago related to application of this oleogels in the related field, dairy and food. And at the last, I will conclude my lecture with the future perspectives, advantage, disadvantage related to this concept. So first of all, why oleogels concept is bringing behind oleogels concept was bringing recently. Why? Because as we know that the solid fat is mainly responsible for the textural, physical, sensorial and aroma development of the food materials. But saturated fat is also related to the many non-communicable diseases such as cardiovascular disease. So few years ago, researchers seeking alternative of saturated fat. And what are the alternatives? That is vegetable oils. So vegetable oils, why vegetable oils? Vegetable oils is rich in unsaturated fat, that is healthy fat compared to saturated fat. But development of necessary textural, body and sensorial attributes, it is necessary that food commodity has solid fat. So we have to researchers need to transform the vegetable oils into the solid fat, partially or fully. So partially it was possible through the chemical modification. And what was the chemical modification? That is the popular method was the transification. So which results into trans fat. So what is trans fat? Trans fat is the method of processing of solid fat and liquid fat into the solid fat by the partial hydrogenation by chemically convert the double bond of the hydrogen into the single bond. So, but trans fat is not considered as healthy. US FDA banned this trans fat, and later on, WHO also released notice regarding it, that is replace trans fat. Also, they advise that intake of total fat, saturated fat, and trans fat should not be more than 30%, 10%, and 1% of total energy intake, respectively, in 2019. So, after that, the researchers, or we can say in industries, looking forward for the alternative. So, what can be the alternatives of bad fats which can replace without changing in processing characteristic, without changing in technological and sensorial qualities, and with maintaining the consumer interest in products, also complying with the all national and international regulation. So the concept bringing up, that is oleogelation. So what is oleogelation? So oleogelation is nothing but it is a potential solution for the problems which I mentioned earlier, that and it is defined as the complex microstructure system where edible oil is physically entrapped within a thermoreversible 3D gel network using suitable oleogelator, that is known as oleogelation. So basically, in formation of oleogelation, two components is required. That is, first is organic solvent and second one is gelator. So not oleogelation is just a structuring of edible oil into the partially solid structure. So if I'm going in deep of what are the components of oleogels, so what I said, oleogelator is the first component. So it is a main structuring agent which is used into preparation of oleogels. How it works, we require only less than 2% on the weight basis to structure the edible oils or oleo, the final product, that is oleogels. But there are some properties which is defined to be oleogelator. And what are the properties? That is, first and foremost is lipophilic presence and interacting parts. Lipophilic presence is required. Why? Because there is oils. So there should be some molecules which will make the interaction between these two hydrophilic and hydrophobic parts. Another one is thermoreversible. Yes, they should have these properties. Why? Because we are going to be varying processing conditions. So it should be thermoreversible as we require during the processing condition of food products. Another one is surface activity. Surface activity is responsible for hydrophobic interaction. Other than that, it should be originated from natural resources. It should have generally recognized as safe status and also economical. That should be feasible if we go on if we'll go for future if we'll go in future for large scale production. So another important part is edible oils. For edible oils like which those oils which have large content of unsaturated fat, that is rich in unsaturated fat, that those only edible oils are considered for formation of oleogels, because we have to make a healthy system. So there are some factors which define the oleogels properties. The first is degree of saturation. Degree of saturation, we know that how we know the degree of saturation of oil and fat by the iodine number. So iodine number is say that the number of double bond in the oils, that is the iodine bond side. So lower the saturation, then higher the iodine number. So low saturated oils are required for the edible oils. Polarity, if I say polarity, the edible oils are mainly non-polar. So it should be lower polarity is required for making suitable oleogels for food products. Another one is viscosity. High viscous oils are required for designing oleogels. Why? Because if it is lesser in viscosity, then it will hamper the crystal size of oleogels. If it is high in viscous, then it will give a small crystal size in final oleogel product. Last but not the least is unsaturation. As I said, that it should be healthy. So we need more and more unsaturated contents in the edible oil. So we select those oils only which is high in unsaturated bond. So on the type so oleogelators are basically categorized on the two category on the larger basis. First is low molecular weight and another one is high molecular weight. So what is low molecular weight? Waxes and select phytosterol, these are low molecular weight. So on the basis of molecular weight, they also have something different characteristic compared to high molecular weight. What it does self-assemble to create a stable crystals network to form oleogels, and this network can be controlled by temperature and shear force. While high molecular weight such as polysaccharide and proteins like oleogelators entrap oil when forming 3D network via hydrogen bond and display viscoelastic properties, which is depends on mainly polymolar molecular weight and their concentration. If I talk about waxes and select-based oleogels, so they are mainly follow the direct method. I will discuss what is the direct method later. Here we will discuss what are the advantages and disadvantages and application of these different oleogelators. So mainly advantage with waxes and silac based oleogel preparation is it is easily available, it is economically feasible, and it is also food grade fabricated, oil in water emulsion with or without emulsifier, also thermo reversible, and its application in sprayed or shortening alternative preparation. Another one is the phytosterol based oleogel, which is also a low molecular waste oleogelator. So in this categories, beta cytoestrol and gamma originol is a popular phytosterol, popular oleogelators, which is found that synergistically develop strong gels compared to others, and also it has a oil banding capacity increase with the variation in the ratio of these two with oil. Other than that, we can add emulsifier to it to improve the physical stability and functional property of the gel. Next one is high molecular weight oleogelators. As I said, polysaccharides and proteins are higher in molecular weights. So in polysaccharides, ethyl cellulose is very popular polysaccharide, which is used in preparation of oleogels. Ethyl cellulose has nature of forming gels by direct method. How? So it forms rigid interaction via hydrogen bond, which create 3D network from polymer strands, and it affected by the its molecular weight, temperature, and type of edible oil which we are using to develop the oleogels. Other than that is proteins. Proteins has hydrophilic natures, so it doesn't form gel in hydrophilic oil. But there are two strategies to form gels by using proteins, and these are the emulsion template method and solvent exchange method. And this two method is also known as indirect method. So what are the mechanism behind preparation of oleogels is, first is crystalline particles. Crystalline particles is what? Crystalline particles, we can say ethyl cellulose is the best popular, one of the popular oleogelators, which has property to form the crystal size, crystals particles in the oleogelation preparation. Other than that, we can generate crystals particles through monocomponents, such using natural waxes, monoacyl glyceride, and diacyl glyceride. We can also develop crystal size particles through mixed system, and in that we use fatty acid with fatty alcohols, phytosterol with monoglycerides, and sorbitan esters with phospholipids. Crystal particles are mainly developed in this system, needle-like or platelet-like system. Second one mechanism is self-assembled structures developing, and through that we can develop oleogels. And in this characteristic is achieved by, if we are using monocomponent, then we have to use self-assembled fibril network formation forming fatty acid, that is 12-HSA and REA. Other than that, sphingolipids has also characteristic to develop the gel by self-assembling structure development. Mixed systems, in mixed system, phytosterol is used along with the sterol esters, and phospholipids is also used along with tocopherols. Third popular mechanism is also developed, that is direct and indirect method, which I will discuss after this. That is direct method, we use cellulose derivatives. I have said ethyl cellulose is very popular in preparation of gel using direct method. Indirect method is basically designed for the higher molecular weight oleogelators. So hydrophilic cellulose derivatives such as methyl cellulose and high proxymethyl cellulose, hydrophilic proteins such as beta lactoglobulins, it is a type of protein. Hydrophobic proteins, that is gene, it is also a type of protein. Protein with polysaccharides, this is also polysaccharide is high molecular weight components. So when protein with polysaccharide is used, then also it go with indirect method. Other things are categorized under miscellaneous, and in that we use inorganic particles. Fumed silica is also used to develop oleogel system. And emulsion template I have I have shown in the previous slide that emulsion template method is used. So emulsion droplets we mainly generate by using HIPE gels, which I will discuss after this. So what is crystalline particles? So gelator, in this, we use gelator at particular concentration, or we can say very low concentration, to develop crystal network, and which develop gels network that is able to retain oil and promote solid structuring upon cooling. It is very cost effective because exhibit high oil binding capacity at very low concentration. But there are some factors which affect their gel network system, which is depends on mainly chemical composition of gelator, which exhibit gel formation of needle-like or platelet-like crystals network. If I talk about self-assembled network, then self-assembled network, I have said in gelators, we mainly use polymers, lecithin. What is LMOGs? So original with phytosterol is mainly used for self-assembled network in this category. And it is a very recent research which is done on this particular molecule, and it's found that it produces tubular shaped arrangement which has ability to generate a network using self-assembled fibril networks formation, and it forms translucent gel with the length of the fiber which is highly dependent on the cooling rate and storage temperature. So the cooling rate, the rate of cooling and temperature where we store it, it will hamper, or uh, it will somewhere affect the length of fiber which is generating during formation of oleogels, and somewhere the length of fibers will also affect our firmness of our gel formation. So during application of this oleogel, such type of oleogels will affect our processing condition also. So in this category, we have used 12 HSA REA. This type of component is used for this mechanism to develop oleogels. Another was a polymer network. So in this polymers network, as the name named assemble, that it entrap oil in an entangled polymer network, which is formed via direct or indirect method. So this network can be created by the direct or indirect method. So the popular was ethyl cellulose, methyl cellulose, hydroxypropyl methyl cellulose, and GMT. These are the compounds which generate the gel through polymer network. Ethyl cellulose is a popular form of components which produce gel through direct method, and it is generated through the dispersion of ethyl cellulose in oil interaction of polymeric chain via hydrogen bonding. So indirect method, mainly hydrogen bond is responsible to generate a gel network system. So as I have said, there is two type of method to generate the oleogel. The first one is direct and another one is indirect. So what is direct method? So it is basically direct dispersion method. In this, what we do, edible oils and melted oleogelators is mixing together and heating above their melting point. So what happened when they are heating? They mix it properly, and after that we use magnetic stirrer or ultra-thorax, because there are some resistance to be mixing together. So to develop a homogeneous system, we have to use ultra-thorax and magnetic stirrer. After that, we subsequently process it to cooling system. When it is cooled down, we can see here it develop a gel system which is known as oleogel. Another method is indirect method. In this, we will see the first is indirect emulsion template method. So in emulsion template method, what we do, the oil in water emulsion we will take and with interacted with polysaccharide. So what it happens, the oil droplets is generated in such system. This like circular is oil, and the polysaccharide is incirculated from the circumference. So this polymeric network revealed after when we generate the polymeric network, it will after removal, it will reveal like this. So when we shear the product, it generates the homogeneous network of oleogels. So what is the in this system we use protein molecule to develop oleogels. So what we do, we use proteins such as hydrogel, and it has a water phase removal. It is also used edible oil dipping method, and polysaccharide can be added to increase the firmness of the oleogels for processing of food product. In indirect dispersion method, what we do, the aqueous phase is interacted with the protein along with polysaccharide system. In this, the protein polysaccharide displacement happen with along with aqueous phase and generate a network which is basically based on the principle of solvent exchange. Here we can see the solvent is exchanging from the aqueous phase to proteins, polysaccharides. So here the hydrogel using protein, hydrogel, we are preparing hydrogel using protein as an emulsifier, which is intermediate organic solvent, that is acetone or tetrahydrofuran. Then the substitution is happening through the dipping or immersion step. So this system is basically working on the solvent exchange method. So where we can use the application in dairy and food industry. So oils and food. If I say about dairy products, why in dairy product oleogels is used? Because as we know that milk fat is rich in saturated fat, and saturated fat is related to our non-communicable disease. So we have to be used in dairy also, the oleogels. So there are major 4 categories where oleogels can be applicable. So what are the 4 categories? That is, first one is meat product, another second one is bakery product, third one is dairy product, and last one is the miscellaneous. So what is the advantage if we use oleogels in these food categories? That it will reduce the saturated fat acid and trans fat. It will also prevent oil migration, which is basically a bigger problem in meat products and bakery products. It will increase the oxidative stability, because we know that when we use high unsaturated oils, there is more chances of oxidation. So through oleogel system, we can prevent the oxidations problems by creating such type of network. Another one is delivering bioactive components. So due to the 3D networks system in the oleogels, we can interact valuable bioactive components into it and deliver through the fruit products. So oleogels can be used for the bioactive components delivery. There are some few researches which is done in the recent years. So in meat industry, we can say the first product which is mostly consumed in global level, that is a frankfurter. So to develop the frankfurter based on the oleogel system, in this research, they use sunflower oil with monoglycerides and phytoesterols in the ratio of 3:1 ratio, or if we can say 20% on the weight by weight basis. So application, it was seen that the 50% it was a success to replace the pork fat in the frankfurter. Another product is the sauces. So to develop the sauces, researchers use the linseed oil along with the phytoestrol and original, that is 8 gram per 100 gram. So it was successfully replaced the 30% of the pork fat in those sauces. A spreadable product, which is a very diverse product currently on the global level. So low fat spread is developed using soybean oil with the help of 2% silac wax as the gelator tab, and where the researchers found that the 100% is possible, 100% hydrogenated soybean oil is possible to replace up to that is the 60% on the weight basis. Other than that is the sorting and margarine. So in this, they use rice bran oil with the 1% sunflower wax, and they succeed to reduce the 40% and 25% palm fat respectively. Another category which is very much lovable to use the oils and fat, that is the bakery industry. And in bakery industry, cookies, cakes, such type of products require lot of oils and fat in their preparation. So in one of the studies done in preparation of cookies using canola oil with 3% candela wax, and they reduce, or they were succeed to replace up to the 30% shortening, which is generally used in preparation of cookies. In cake preparation, uh, study has been done on high oleic sunflower oil with carnauba wax up to 5% application, and it was found that it can successfully replace the shortening in the preparation of cake. Other than that, if you are coming to the dairy industry ice cream. So here the ice cream we are using sunflower oil with phytosterol and oregano. That is a 12 gram per 100 gram. And it is successful to substitute fat, but not completely, but somewhere. Some point it was success to reduce. But as per the rules and regulation, it will be not categorized as ice cream. Why? Because we are substituting milk fat with another vegetable oils. So it may be characterized as not, it will be characterized as frozen dessert, not ice cream. Cream cheese. In preparation of cream cheese, they use high oleic soybean oil, and they use 10% weight by weight rice bran wax to develop oleogels for application in cream cheese, and it was 30%. There was success 30% to reduce the fat in the cream cheese. The last category was the bioactive delivery. So, in the preparation of bioactive component delivery network system, they use canola oil with methyl cellulose with beta carotene. So, what was happened? They found that there was controlled release of beta carotene happen when they delivery through the oleogel system compared to the without oleogels. Another research which is happened on the feasibility of hydroxypropyl methyl cellulose oleogel as an animal fat replacer for meat patties. They use canola oil as an edible oil with HPMC, high proximate methyl cellulose up to 1% to form the oleogel system. Using the foam template method, or they found that the oleogels has nature of high elastic and application in meat patties. They also observed that there was heat losses was very minimum, and it was thermally stable to produce the higher tender texture. It was the highly stable to oxidation reaction, and saturated fatty acid content was significantly reduced to 15% compared to the beef tallow sample, that is the 42%. If you see the organogel as a novel ingredients for low saturated fat ice cream, so here was the key findings, that is the sunflower oil structured with 12% gamma oryzanol and beta cytosterol. So there was the mixed apparent viscosity, that was the 32 megapascal per second, similar to control sample, that was the up to the same level, 32 megapascal second. The overrun was the 42% achieved, and melting starting time was 20 minutes. That is a higher than control sample. What is the in that the overrun was 37% only, and melting point was 16 minutes. Another study was done on the roles of gelated type and gelation technology on texture and sensory properties of cookies prepared with oleogels. So here they use corn oil with 6% HPMC, rice bran wax oil, and they used spread ratio in the higher in methyl acyl glycerol. They found that the lowest hardness in the rice bran wax oil and methyl acyl glycerol. They also found that the beta prime crystal formation with use of rice bran oil, but in the methyl acyl glycerol form beta crystals. We can see here the graph. Here we can see here from the graph of the respective research. Another research on the vegetable organogels incorporation in cream cheese products, and in this they use high oleic soybean oil with ethyl cellulose up to 10% and rice bran wax. They also form a control, which is a commercial and ungelled high oleic soybean oil cream cheese spreads. And they found that except non-gelled control sample, there were no difference in microstructure network, hardness, and spreadability. Ethyl cellulose oleogel samples show lower adhesiveness compared to control, and rice bran wax successfully, which mimic the textural profile of the control sample. There are some limitations with the application of oleogels in this field. That is, the indirect methods are not industrially feasible. But polymer-based oleogelators are shear sensitive and so was thermoreversible property in food preparation when we apply in the food commodity. Wax-based oleogels show different crystals behavior. So there are some modification requirement in the oleogel system development using wax oleogelators. Phytoestrol-based oleogels are also water sensitive. That is the one of the major limiting factor in the preparation of oleogel using phytoesterols. I would conclude my presentation using that or talk that the oleogelation offers possibility to replace saturated fat and trans fat from the processed food. There are the application of oleogel which improve the nutritional value of food product, because we have seen that the bioactive delivery in the bioactive delivery system, this system was feasible and successful compared to the control system. So another one is the natural waxes are more processing structurants for oleogels. So natural waxes are successful in developing of oleogels, which is economically and in the process, if we say as per the processing requirement, it is also feasible to design oleogel based food commodity. And the use of oleogel in food industries is still in infancy, but potential is significant, because still we cannot see any industry which is developing any food commodity using oleogel, because there are some scope for more studies on the base on the concept of oleogels. What are the future perspective in this concept? That is the deep fat frying based processed food such as instant noodles, 6 suitable oleogels. So in the deep fat frying system, where the deep fat frying is required, there it could be not possible to use oleogels, because there would be changes in the their structure, because oleogels are mainly thermoreversible. So there will be some changes in their structure. So they are not suitable for deep fat frying. Another is the fat-soluble molecules such as beta-carotene, plant sterols. It can be incorporated in food through oleogels, which require more study to develop the suitable carrier. Another is the future scope in this field is insufficient knowledge are available on the effect of processing on oleogel preparation. Whatever the studies has happened, it is happened on the developing the replacing the main oil and fats, main oil and fat resources with oleogel system. But there is no any studies still available in the literature that what will be the effect of processing condition when we vary like pH, acidity, and other things, temperatures, pressure. So how the oleogels will behave or react in the food commodity. So these are the some future scope where current researchers or academics or industrial can study in this field. Thank you very much. Dr. Anuradha, ma'am.
Thank you so much, Sunal, for this informative session. Now the session is open for the discussion.